Equations that can be written in quadratic form. This lesson, we will solve equations that are not quadratic, but they are quadratic in form. Remember, quadratic equations are equations that are of this form. This is quadratic. What makes it quadratic is that the highest degree is 2. So that's exactly what makes this quadratic. A, B, and C are any real number with the condition that A is not 0. Because if A is 0, it wipes out the square term altogether, and then you're down to something linear. Now, what I want you to realize is look at the variable part of the middle term. Look at the variable part of the first degree term. This is the first degree term, and look at this middle term. The variable part is x, okay? X. What do you get when you square x? When you square x, you get x squared, which happens to be the variable part of the first term, of the leading term. So that is the pattern you're going to see over and over and over again with these equations that are not quadratic, but they're quadratic in form. What's going to make them quadratic in form is that if you take the variable part of their middle term and square it, you will get the variable part of the leading term. Let's look at the first example here. For this first equation we want to solve, notice that it's not quadratic. It's actually quartic. It's degree 4, so we call it quartic. So this is not a quadratic equation. It's a quartic equation. But I want to show you how it is quadratic in form. Take a look at the variable part of the middle term. The variable part is x squared. If you square x squared, you will get x to the 4th, which happens to be the leading term, the variable part of the leading term. If you square the variable part of the middle term, you'll get the variable part of the leading term, and that's how it is quadratic in form. What we're going to do to solve these equations in this lesson, we're going to make a substitution. Now, here's the substitution that I want us to make. I'm going to say let u, the letter u, or the variable u, represent x squared. Okay, so x squared right here, I'm going to replace this with u. Notice what happens if you square u. If you square u, that means you'll be squaring x squared, which is x to the 4th. So that means u squared just represents x to the 4th. So I'm going to replace x to the 4th with u squared, and I'm going to replace x squared with u. This is how the equation reads now that we made the substitution. Remember, we replace x squared with u, we replace x to the 4th with u squared, and now this equation in the variable u is indeed quadratic. Quadratic. Because it's quadratic, we can use our algebraic factoring techniques to solve this quadratic. Actually, you don't have to factor. You can use the quadratic formula now. But because I'm a fan of factoring, I will factor this. And it factors as u plus 16 times u minus 1. And then, you know, we set each factor equal to 0 and solve. And so you're getting u is either negative 16 or u is positive 1. So you just finished solving for u, which is great. However, the equation said, or the instructions said, solve the equation, and it was in the variable x. We did not solve for x yet. We've only solved for u. So what you need to do at this point, for every single equation that we see in this lesson, you need to reverse the substitution or back substitute. So don't forget what u represents. It's right here. U represents x squared. So where you see u is equal to negative 16, it's really x squared is equal to negative 16. Where you see u is equal to 1, it's really x squared is equal to 1. So this is called back substitution or reversing the substitution, okay? You have to undo what you've done and solve for the original variable. all right? Taking the square root of both sides for each of these will get you that x is equal to plus or minus 4i here, and over here x is equal to plus or minus 1. Notice that you have 4 different solutions here, 4 different solutions. Positive 4i, negative 4i, positive 1, and negative 1. 4 solutions, and this equation happens to be degree 4. 4 solutions, degree 4. That is the relationship whenever you're solving a polynomial equation. A polynomial equation will have the same number of solutions as its degree. Check out this next equation. X minus 12 times the square root of x plus 35 is equal to 0. Now, just FYI, this is not a polynomial equation at all. And that is because this variable x is being raised to the power of 1/2. That's the interpretation of this square root. All right, so what we're going to do is we are going to make a substitution. But before we do, I just want you to notice that this equation is quadratic in form. Look at the variable part of the middle term. The variable part of the middle term is the square root of x. What would you get, everybody, if you took that variable part of the middle term, and what would you get if you squared it? Well, if you square the square root of x, you just get x. And x happens to be the variable part of the leading term. So the variable part of the leading term is the square of the variable part of the middle term. And that's exactly what makes this equation quadratic in form. If you square the square root of x, you get x. If you square this part, you get this part. Now we're going to make a substitution here, and it's going to, notice the pattern, please. It's the same pattern. What we're going to do is we're going to let you, and again, you can choose whatever letter you want of the alphabet. Just don't choose X, okay? You don't have to choose U. You can use A, B, C, D, whatever you want. But I like U. So U, I'm going to let U, the letter U, represent the variable part of the middle term, okay? That's the same thing that I did in the previous equation. Now notice what happens if I square U. If I square U, then I'm squaring the square root of x, which is just x. So I'm going to go back to my equation. Wherever I see x, I'll replace it with u squared. And where I see the square root of x, I'll replace that with u. I've made the substitution. So where x is, I replace it with u squared. Where the square root of x is, I replace it with u. Now this is quadratic. This is quadratic. So you can use the quadratic formula to solve this for sure. You can use factoring if it factors to solve this, all right? Now, whatever you do to solve for u, don't forget that you need to reverse the substitution when you're done, okay? Reverse the substitution or undo it. All right, I'm going to use factoring. So this factors as u minus 7 times u minus 5. And when I set each of these factors equal to 0, I am getting that u is 7 or u is 5. Now, I need to back substitute, okay? Remember that u just represents the square root of x, the square root of x. So when it says u is 7, it really means the square root of x is 7. And where it says u is 5, it's really the square root of x is equal to 5. So now I solve for the original variable, x. Now what I can do here is I can square both sides to solve for x. So let me square both sides. Let me show that here. When I square the left-hand side and the right-hand side for both of these, right? For both of them, that's going to get rid of that square root so that you can solve for x. Squaring both sides. So then we're going to get that x is equal to, right, 49, or x is equal to 25. Now, let's check these solutions in the original equation. Here's the original equation, and what I'm going to do is I'm going to plug in the numbers that I found. So 49 minus 12 times the square root of 49 plus 35 is supposedly equal to 0. All right, so this is 49 minus 12 times 7 plus 35 is equal to 0. I'm going to go ahead and add these positive numbers first, okay? So I'm going to add 49 and 35 first, and 49 plus 35 is 84, and 12 times 7 is also 84. 84 minus 84 is 0, so this definitely satisfies the equation. X equal to 49 is indeed a solution for this equation. Now let's check 25. All right, substituting in 25 in the original equation gives me 25 minus 12 times 5 plus 35 is equal to 0. Now 25 plus 35 is 60. 12 times 5 is also 60. So this indeed works. 25 also satisfies my equation. And so I have two solutions, 49 and 25. Check out this next equation. It's n to the power of 2/5 is equal to n to the 1/5 plus 2. The first thing I really want to do is set this equal to 0. The previous two equations that you and I were looking at, both of them were set equal to 0 already. This one is not. So I'm going to set this equal to 0 by collecting all my terms on one side. And I'm going to choose to collect all my terms on the left side because I want my leading coefficient to remain positive. So basically, I'm going to subtract these two terms from both sides. Now, when I do, I end up with n to the power of 2/5 minus n to the power of 1/5 minus 2 is equal to 0. Now, I want to show you how this is quadratic in form. If I take the variable part of the middle term, which is n to the 1/5, and if I square it, notice that this gives me n to the 1/5 times 2, which is basically n to the 2/5. So basically, which is the leading term, the variable part of the leading term. So basically, the variable part of the leading term is the square of the variable part of the middle term. Meaning, if you square this part, you get this part. And that's why this is what we call quadratic in form. Let's make a substitution so that we can solve this. So here's our substitution, guys. And please, please, please notice that it's the same pattern. I'm letting u represent n to the 1/5. N to the 1/5 is the middle part, the middle variable part. It's not the entire middle part because I'm not taking the coefficient, -1, right? I ignore the coefficient. I just let u be the variable part of the middle term. And then I square my variable u. But if I'm squaring u, that means I'm squaring n to the 1/5, which becomes n to the 2/5. So what this means is, where I see n to the 2/5 in my equation, I'll replace it with u squared. And where I see n to the 1/5, I'll replace it with u. Now this equation is quadratic. Not just quadratic in form, it's quadratic. So you can use the quadratic formula or you can try to factor this. It's not guaranteed to factor, but I do see that it's factoring. If it didn't factor, or if the factoring just seemed too challenging for me, then I'd probably just solve it using the quadratic formula. So I'm solving this for u at the moment, and I'm getting that u is either +2 or u is -1. Now remember, we need to back substitute or reverse the substitution. So you have to remember what u represents. U represents n to the 1/5. So when we say u is 2, it's really n to the 1/5 is 2. And where we say u is -1, it's really n to the 1/5 is -1. So now we have these equations in the original variable, all right? Now we need to solve for n. We can solve for n if we raise both sides to the power of 5. Let me show you that now. If I raise this side to the power of 5, I have to raise this side, obviously, to the power of 5 as well. And remember that by the power rule for exponents, this would be multiplication, 1/5 times 5. And 1/5 times 5 is just 1. So then all you're left with on the left-hand side is n, n to the power of 1. And on the right, you have 32, which is 2 to the 5th power is 32. So here's one solution for you. Same thing for the equation on the right. We're going to raise both sides to the power of 5. And I want you to notice that 1/5 times 5 is just 1. So then you get n to the power of 1, or just n, is equal to -1, right? -1 raised to the 5th power is still -1. So then you have these two solutions for this equation. All right, check this equation out. And this one is actually quadratic, to be honest with you. If you were to expand this by rewriting it as 2a minus 3 times 2a minus 3 and distributing and combining like terms, and then distribute the 4, and then combine like terms, and then subtract 12, set this equal to 0, combine like terms. It sounds like a lot of work, but it can be done. You're going to get an equation that is quadratic. Now, I also want you to notice that it's quadratic in form like the other ones, in that if I take this part here, 2a minus 3, take that part, and if you square it, you will get 2a minus 3 quantity squared, which happens to be this part. This part here, this leading term here, is the square of this part. So I'm going to make a substitution just like I made a substitution for the other equations. But before I do, let's get this 12 to come over so that this equation can be set equal to 0. All right, I brought the 12 over like I said I would, and here's the substitution that we're going to make. You're probably used to this now. You can see the pattern. We're letting u equal the variable part of the middle term, right? This part here. And then when you square u, you square the expression 2a minus 3, which happens to be this whole first term. So I'm going to replace 2a minus 3 quantity squared with u squared, and I'll replace 2a minus 3 with u. And I'm left with something that is quadratic, but it's simpler than the original equation. And I'm going to use factoring to solve this. U plus 6 times u minus 2 would be how it factors. Again, I just want to reiterate as I continue working here that you can use the quadratic formula if you like. I think factoring is many times faster. I'm already done, and I think the quadratic formula, I'd still be, writing everything out. So this is what we have. Now, we have to reverse the substitution. Do you remember what u really represents? U represents the expression 2a minus 3. So I'm going to replace this u and this u with the expression 2a minus 3. So now I have these two linear equations, and all we need to do now is solve for a. So for this first equation, well, actually for both of them, we'll add a to the right hand, we'll add 3 to the right hand side. Really, you're adding 3 to both sides, right? And so when you add 3 to -6, you get -3. When you add 3 to 2, you get 5. And then we'll divide both sides by 2 to reveal our final answers of 3 halves and 5 halves. -3 halves, not +3 halves. All right, so then these are our two solutions, -3 halves and +5 halves. This will be the last equation that you and I look at for this lesson. Notice that it's already set equal to 0. That's fantastic. Also notice that it's quadratic in form, because if you take the variable part of the middle term and if you square it, remember the power rule for exponents would have you multiplying these powers, these exponents, and you get n to the -2nd, which happens to be the variable part of the leading term. So once again, this part is the square of this part. So because it's quadratic in form, you and I can make a substitution like we did our other for the other equations. I would invite you to pause this lesson here and try this on your own using the pattern that we've been following all along. So here's our substitution. I'm letting u represent n to the negative first, which is the variable part of the middle term. And when you square u, then that means you're squaring n to the negative first, which gives you n to the negative second. And so wherever I see n to the negative first in my equation, which is here, I'll replace it with u. And wherever I see n to the negative second, which is here, I'll replace it with u squared. So with this substitution, you get 2u squared minus 7 times u plus 3 is equal to 0. Now this is quadratic. It is quadratic, not just quadratic in form, but quadratic. You can solve for u using any of your quadratic techniques. I like factoring a lot, so I'm going to factor this as 2u minus 1 times u minus 3. All right? And then I'll set each factor equal to 0. And for this left-hand side, I'll add 1 to the right, or to both sides, excuse me, and then divide by 2, so you get u is 1/2. Over here, you're getting u is 3. Now, we have to reverse the substitution. U represents n to the negative first. So I'll replace this u and this u with n to the negative first. Now we have two equations in the original variable, all right, in the original variable of n. Now we need to solve for n. So if I raise both sides to the power of -1, that will get n isolated. That will isolate my n value. Now let me show you my n variable. Now let me show you what happens when you raise both sides to the power of -1. By the power rule for exponents, we know that when you raise n to the negative first to the negative first power, you need to multiply these two exponents. And -1 times -1 is +1. So you get n to the power of +1. Now, raising 1/2 to the power of -1 will reciprocate this number. So it'll become, instead of 1/2, it'll become 2/1. But 2/1 is just 2. So there's one solution. N is 2. Now let's do the same thing over here. You have n to the negative first is equal to 3. So let's raise both sides to the power of -1. That will isolate our variable. Okay? So you're just getting n, correct? And when you reciprocate 3, when you flip it over, if you will, instead of it being 3/1, right, there's an invisible 1 as a denominator here, you get 1/3. The reciprocal of 3 is 1/3. So then your two solutions are 2 and 1/3. All right, I hope you enjoyed solving these equations that are quadratic in form. I know I did. So good luck working on these kind of problems, and I'll catch you in the next lesson.